Hello students. So today we're going to combine budgets with indifference curves. We developed the properties of indifference curves earlier. Last videos were about budgets. So now we're going to put them together. So we'll consider several possibilities and see what optimal consumption could look like. So let's say our two goods are X and Y. So if you have a bundle A back here, bundle A can't be optimal. So again, remember by optimal I mean the best bundle you can afford. Recall we said that with the budget line you buy everything on the line or inside it, but not the things that are outside it. So the problem with bundle A is that there are some better bundles that are still affordable. There's a bundle out here. This one contains more of both goods, but let's call it bundle B. So because more is better, we know B is preferred to A, and B is affordable, so A is not the best. So in general, whenever you draw, or whenever you pick some point inside the line, like back here, that's never going to be the best. You have to be on the edge, you have to be on the frontier to be optimal. But not all points on the frontier are optimal. So you have to be on the frontier to be optimal, but just being on the frontier by itself, that doesn't guarantee that it's the best. So let me show you what I mean by that. Let's pick a bundle that is on the frontier, but is not the best. So that could be some bundle like this one. Let's call it bundle C. So it turns out that C is also not the best, even though it's on the frontier. So to show that C is not the best, I gotta find a bundle that is both better and still affordable. So a bundle like this one, for instance, let's call that one D. So you could compare D to some other bundle back here in the same indifference curve, like this one. Let's call it one E. So you know C and E are both equally good. Remember, indifference curves connect all bundles that are equally desirable. So C and E are just as good as each other. We also know that D is better than E. That follows from more is better. D has more X and also more Y. So if you could put this together, D is better than E, and E is just as good as C, transitivity would tell us that D is better than C. So if D is affordable, because it is on the line, and it's better than C, that means C can't be the best. So that's how I know C is not optimal. Another possibility to rule out, we have some bundle way out here. Let's call it bundle F. That's also not optimal. It's great that it's very far out. Remember, more is better, so we want to be on the highest possible indifference curve. Unfortunately, F is just not in the range of things we can afford. We can afford everything on the line or inside it. F does not meet those criteria. So again, when I talk about optimal consumption, I mean, what's the best thing that I can afford? This, I can't afford. So there is one last case that turns out that it works. Let's say I bundle G over here. Now that turns out to be optimal. So first you gotta verify it's affordable, and it is. We're on the budget line. But to be optimal, it has to be the best bundle we can afford. And it is. So everything better than G would be everything above this indifference curve. So everything out here is also that's better than G. So this whole region above the curve is all the better than G. As you can see, however, everything that's better than G is not affordable. So that means that G is the best that we can afford. So G is optimal. So there are some special things about point G on our graph. So at bundle G, the slope of the indifference curve and the budget line are the same. So these curves are tangent. contrast that with what we had back here. At point C, the indifference curve and the budget line were not tangent. They had different slopes. The indifference curve was steeper than the budget line was. But G had the same slope at that exact point. So what's so special about that observation? Well, we had a name for the slope of the indifference curve. Do you guys know what that name was? The slope of the indifference curve? It was the MRS, the marginal rate of substitution. And that also equaled, we said in a earlier part of this appendix, that the MRS was the marginal utility ratio. So the marginal utility you get from X divided by the marginal utility from Y. We talked a bit about the slope of the budget line in the previous video. So that was back over here. So we rearranged our budget line and we got this last time. And we said the intercept was this term over here, and the slope was the price ratio. So you put this together saying the slopes are equal at this point. That means this is equal to that. So when you're optimizing, the marginal utility ratio equals the price ratio. If you reshuffle this a little bit, let's say we divide both sides by px and multiply both sides by muy. What you get is mux over px equals muy over py. An equation that may look familiar. You saw this one way back in Chapter 16. This was our rule for optimal consumption. So you take that rule you learned about way back in week 3 or so, and you try to show it graphically, it's going to look like this. So the idea you learned about back in Chapter 16 is connected to all this indifference curve stuff that we're learning now in the appendix. So that's all I want to talk about from the Chapter 16 appendix. Best of luck on the final.